So I welcome you all to this particular course of algorithms and problem solving. So in this particular semester, we are going to cover the various contents. Like before I proceed further, what I'm going to discuss today is the course outline, the course outcomes. That is very important. These course outcomes, they help you understand after the completion of this particular course, what we are expecting from you with respect to this particular course. Then what will be the evaluation criteria for the various, you can say, but various assessments which will be there throughout the semester, and what are the relevant resources you can refer to besides the contents or the study material that will be provided with respect to the lectures. So in this particular course, the various topics that we are going to cover, they include, first of all, introduction to the problem solving approach. And within that topic, what to cover is the asymptotic analysis. That means how the performance of the algorithm, you can say whether it improves or it decreases with the increase in the size of the data. So what is the effect on the algorithm depending upon the change in the size of the data that we call as the asymptotic analysis, that is the growth of functions. So that means how it is, whether it is increasing linearly, it is, you can say the complexity is increasing exponentially. So that we call as the asymptotic analysis of the algorithms that we are going to discuss from the very beginning. So we'll start our classes with this particular topic only. Then we'll be solving the recurrence problems. Then learning about when we are doing the asymptotic analysis, we will be discussing the various kinds of notations that are being used, like big O, big omega, big theta, little o. Then the empirical analysis of the sorting and the search algorithms, that is basically reflect the first category of problems that we solve when we are dealing with. See, when we say the algorithms and the problem solving, then we say what kind of algorithms are there and what kind of problems are there. So here you can say these various modules, they are basically reflecting the kinds of problems that we come across in the real world. So the first problem that we come across, that is related to the sorting. So we all know, we learned in the very class one, arrange the numbers in the ascending order or descending order, and that we have been doing it manually. But as the size of the data increases, what kind of techniques or the algorithms they are suitable for solving such kind of problems, right? So because we are in the current scenario, we are dealing with the problems which are, you can say, which have to, we have to deal with large amount of data. So how does, see, for doing the same task, we have multiple algorithms. So why do we need multiple algorithms for doing the same task? That means all these algorithms, we have 7, 8 algorithms doing on the task of sorting only. So why do we really need so many algorithms for doing the same task? So sorting algorithms here, some of the sorting algorithms you have already studied. Can anyone tell me why do we need so many algorithms for sorting? Any one of you?
Ma'am, to perform it more efficiently.
Yes. So that means one algorithm may be suitable for a particular kind of scenario, but in the next scenario, this algorithm may not perform well. So for, you can say, for the another kind of scenario, we need some other algorithm which performs well in that kind of environment. So we need, this is the main purpose of having the multiple algorithms for getting the solution for one problem, right? So one problem, the size, it may be the size of the problem is changing, the complexity of the problem is changing. So there are number things which may vary when we are talking about the same problem. Like the problem is of sorting, but what kind of data we are getting when we have to sort the data? It may be at a very first chance we are getting a fully sorted data. In that case, any algorithm will do well. But if the algo, you can say if you have got the worst case that the you wanted to sort data in the increasing order and the data is there in the decreasing order, right? So in that case, which algorithm will perform well with Now you can say which algorithm will perform well. We estimate in terms of efficiency. Efficiency is estimated in terms of the time it is going to take. That means it may be that one algorithm is giving the result faster and the other algorithm is slow on doing the same task. So in case of we can say the sorting, so we can say sorting is one of the problems for which different types of algorithms have been designed. And you can also come up with any of the new algorithms. You can create a new hybridization of the algorithm, and you can prove that your algorithm may be better in terms of time, or it may be better in terms of the space complexity. That means it is taking less space as compared to the other competitive algorithms which are existing. Similarly, the other category of problems that we have, the searching problem. Searching, see, Google search we talk about, that is also a searching, but you can understand the kind of algorithms which are being used for the Google search engine, because even if we have to search the data in our own system, how much time it is taking, and we are talking about Google search engine which has crawled petabytes of data, and from that petabytes of data you can say Google is providing the relevant answers to our queries. So you can understand the you can say the strength of the algorithms which are being used by the Google search engine, and the results that we are getting, they are in milliseconds or the microseconds. So we have to understand the searching is a very important problem that we are dealing with in the current scenario. All the search engines are tackling this particular problem. Then we have the search tree. So you can say this is in order to see, when we are talking about the algorithms, along with that we also talk about the data structures which are used to. So data structures also play a very important role along with the algorithms, because they help in the kind of data structure we have used for the storage of the data. So that plays an equally important role over here. So you have studied about the data structures in the previous classes. Now we are going to, then the next topic that we are going to study is about the search trees, where in the module 2 we will discuss about the interval tree, arbitrary priority queues using binomial and Fibonacci heap. Then the another strategy for solving the problem. See, we can solve the problem. See, either we have the, like in the sorting also we have the you can say the methodology, simple methodology to solve the problem, or you can say we can solve the problem using the divide and conquer strategy. So break down the bigger problem into the smaller problems, and then try to solve the smaller problems, and then you integrate the results. So this is how, when we are working with the divide and conquer strategy for solving the problems, so the algorithms work. So these algorithms start working better and better when we are trying to solve the problems. Then we have the greedy based solution approach. In the greedy based solution approach, what we try to do is we try to take the step which gives us the best, uh, you can say, immediate output. So you can say we are being greedy when we are taking the step. If, let us say, when we are traveling, we say we are at a certain point that we have two directions. In one direction it is 20 kilometers, in another direction it is 15 kilometers, and we leave aside everything and we take the direction where we have a distance of 15 kilometers. So that means we are being greedy at this particular point of time. So when we are talking about greedy algorithms, sometimes these greedy algorithms, they seem to be the best in the short run, right? But in the long run, they are not. They don't provide us the best solutions, because when we you can say when we combine together the number of, if we take the example of this travel only. So in that case also, if we collectively take from the source to the destination the number of kilometers that we have covered, in the every step it seems that this is the best step. But when we combine together, we say that we have actually covered the longer distance, a large number of kilometers as compared to the other options. So it's sometimes this is the problem with the greedy based solution approaches. Then we are going to review the backtrack based solution approaches, where for every step we are going to see, if we try to basically, rather than taking the steps, we try to evaluate each step. And then if we are stuck, we go back and take the second option. So you can say we try one step, and then if we are not able to reach to the solution on this particular step, then we go back. So that is called as backtracking. So we are going to cover the such kind of problems where we have to backtrack in order to find out the best solution. So there we are going to cover the M coloring problem, Hamiltonian cycle detection, traveling salesman problems. Then the next we are going to cover the dynamic programming based solution approach, where we are going to try to solve the knapsack problems, shortest path using the Floyd Warshall, and so many algorithms are there which we are going to we are going to learn in order to solve the dynamic programming based solution approaches. Then we will go for the try to solve the string matching problems. String matching problems are very popular these days. Like in the natural language processing, we are trying to find out the matching strings. They are popular in the field of biotechnology, where they are trying to find out the genome sequence. Like most of the people who are not aware about the genomes and all, they are aware because of the COVID-19. Because it almost took more than a year for the scientists to design and develop the vaccines for the COVID. So, because they were trying to find out understand the genome sequence of the coronavirus, and then on the by after understanding that, they were able to develop the vaccine for that particular COVID-19 virus. So you can say for there everywhere we are talking about the string matching problems. So string matching problems, you can say they are very popular in the biotechnology and the other application domains also. Then we are talking about the problem spaces, like you can say these are related to the artificial intelligence. You can say these problem spaces, that means we are trying to understand the search space when we are searching for a solution. So how much space is available for that? That means whether you, let us say if we take some numerical problem, whether you have to find a solution between the range 0 to 1, or you have to find a solution between -1 to 1. So you can see if it is 0 to 1, and then -1 to 1, -1 to 1 is a larger space as compared to 0 to 1. So this is called as a state space, and we are looking for the solutions to such kind of problems. And we have different kinds of problems like uninformed search. These are your BFS, DFS, these algorithms you have already studied in the data structures, and they are also there in this particular course also. Then besides this uninformed search, we have informed search and heuristic search strategies, and we'll be studying about the hill climbing and the genetic algorithms and the A-star algorithms. Then we will be talking about the efficiency and tractability, and we will categorize the various kinds of problems that we have studied as polynomial time, and then you can say NP complete problems and NP hard problems. So this is all we are going to cover during this particular course. These are the contents that we are going to cover in the algorithms and problem solving course, and the various kinds of problems that we are going to discuss. And for the time being, as of that, we have planned in your T1, we are going to cover the modules 1, 2, and 3. That means till the topic fundamentals of divide and conquer approach using binary search, quick sort. So these are the first 3 modules that we have planned to cover for the T1. So you can see the tentative syllabus that will be there in the T1 is module 1, 2, and 3, and for the T2 it is module 4 and 5, and for the T3 is going to be 6, 7, 8, 9. That the content that we are going to cover, and the major part will be there from the last part. You can see the 6, 7, 8, 9 modules, and some percentage will be there from the previous modules. So this is the tentative bifurcation of the modules that we are going to cover for the T1, T2, and T3. Then when we are studying about this particular course, after the completion of this course, you can say at the end of the semester, so we expect you that you should have the ability to analyze the complexity of the different algorithms using the asymptotic analysis. That means if we give you certain problems, and you have to, we can ask you to tell us what is the complexity of these algorithms. So that means how many swaps it takes, and what is the worst case complexity, what is the best case, what is the average case. So you should be able to do that. So you should have the ability to analyze that. So these are the cognitive levels that reflect what kind of ability we are expecting. Analyze means you should have the ability to do this kind of analysis. Then the second CO says that select an appropriate data structure and apply related operations for a given problem. That means we can give you certain scenarios or certain case studies, and we can ask you to think over the kind of data structure that will be suitable for this kind of problem, and then apply the various operations for solving that particular problem. So you should be able to apply, and you should have the ability to think over what data structure is suitable for that kind of problem to be solved. Then the third course outcome is apply algorithmic principles for solving the given problem. That means for solving a particular problem, what algorithm is the most suitable algorithm for that particular problem. So you should have the ability to apply and provide the solution to that kind of problem, and you should have the ability to think over what which algorithm is most appropriate for that particular problem and why it is the most appropriate. So you should have the ability to develop the reasoning for that particular problem. And then finally, you should have the ability to identify, formulate, and design an efficient solution to a given problem using appropriate data structures and algorithms design technique. So that is create level that will be covered, you can say, with the help of certain, as you will be provided certain assignments where you will do this particular task. That means you will understand the case study, and then you will design, you can say, the solution, and then you will implement that particular solution using the programming, using some programming language. And this part will be there in the assignments, as well as in you're going to have the in your labs, you will be having one project. So you will be doing this particular task in your project. So you should have the ability to create something, design something new. So in the evaluative components, we have T1, T2, which are 20 marks, as you already know about this. Then you have end-term examination, that is of 35 marks. Then you have the fourth, that is the teacher's assessment, or you can say TA, which will include the attendance. You will get the marks for the attendance. PBL is the project-based learning. That means you will be doing one project that is part of the lab, and in with respect to the theory course, you will be provided certain assignments. So that means the project that you will be doing, the marks for that project that you do in the lab, they will also be counted in the theory. So that means a component of the marks that you get in the lab for doing the project, they will be part of this theory course also in the TA. Along with that, you will have certain assignments for T1, T2, and T3. So you can say the combination of all the three components is going to make the total of 25. That makes the total of 100 for the course. So these are the various books. You can see the Corman is, you can say, the base book that we are going to refer. So you can, we have a hard, soft copy of that. We'll provide you the PDF for the Corman. So you better start reading that particular book every day along with the lectures. So the things will be simplified if you study that book along with the lectures every day. And these are the other books which are supporting books. You can refer to them if you wish to. If you are not able to understand certain concepts from one book, then you can refer to any book that you find easy to understand. Along with the books, you have other e-contents and platforms which are available. So you can, in the NPTEL also, you have certain courses which are running, like the design and analysis of algorithms, introduction to algorithms and analysis, and algorithms, fundamental algorithms, design and analysis, programming, data structures and algorithms. These are the various courses which are available in the NPTEL. So you can refer, and they have their YouTube lectures also. So you can listen to if you wish. So these are the extra help that you can avail as and when required. Then you have resources from MIT, Stanford, Cornell, Geeks, and then you have a virtual lab where you'll be doing the experiments related to the course. So in the module 1, we are going to start with the introduction to problem solving approach, asymptotic analysis, growth of functions, and solving recurrences, where we will cover the notations big O, big omega, big theta, little o, empirical analysis of sorting and searching algorithms, like merge sort, quick sort, heap sort, radix sort, count sort, binary search, and median search. So these are the various topics that we are going to cover in module 1. So we will start with the module 1 today. So what is an algorithm? Who will tell me? Yes, who will tell me what is an algorithm? How do you define an algorithm?
Ma'am, these are the steps to do a particular problem, to complete a particular problem,
To solve a particular problem.
solve a particular problem. Yes,
Yes,
ma'am.
algorithm is basically uh, a combination or a sequence of steps which are required to solve a particular problem. Or you can say it is a computational procedure that takes some value as input and produces some value or a set of values as the output. So it is basically a sequence. We say algorithm is nothing but a recipe, isn't it? So recipe, like if I tell you to tell me the recipe of the how to make tea, so in that case, what are the steps you are going to take? So making a tea, that is some problem that you're trying to solve. That means some task that you have to do. So what is the task that you have to make the tea, and how are you going to do that particular task? So how is answered by the algorithm. That means how means what are the steps that we are going to take in order to solve that particular problem. So that is a finite sequence of steps. We cannot have infinite sequence of steps for solving a particular problem. So we have to stop when we have found the solution. When the tea is ready, we have to stop. We have to serve. So here also, when you can say when the problem is solved, when the problem is solved, we have to stop that particular writing the steps, right? So we say it is a well-defined computational procedure that takes certain input and then returns certain output. And this output may be a single value or multiple values. Similarly, the input may be single value or the multiple values. Like the task of sorting, like if you are given the task of sorting, you are given certain numbers, let us say 10, 30, 50, 78, 98. You are given 5 or 6 numbers, and now I tell you to sort these numbers. So for sorting these numbers, you will be writing certain steps, right? So whatever steps you are writing, that is called as the algorithm. And when we talk in the generic terms, let us say A, B, C, D, E, F. These are the 5 numbers, and when we assign the certain values to these numbers, like A, B, C, D, E, F, these are the general values, general terms, and I'm assigning certain values like 78, 25, 34, 19, 15. So these are the values which are assigned to these alphabets. So I say the values which are assigned to these generic terms, they are basically the instances of these terms. So you can say this is called the instance of an algorithm, that is the input to that algorithm at a particular instant of time. So we are trying to solve the particular problem using certain algorithm, and for that, for at a particular instant, the input to that algorithm is called as the instance for that particular algorithm. Now, when we say this input is called the instance of the sorting algorithm, so which algorithm is best? Like all of you have studied about the what are the various sorting algorithms. So can you tell what are the various parameters on which the performance of the algorithm depends? Yes, please. Who will tell me that the various parameters
Time and space.
Time and
besides that? So time and see, time and space also depends on something, no? Yes, number of comparisons is fine. So the number of comparisons, see, if we are coming, so you're coming from the bottom to top. So we said time and space complexity. Then from time and space complexity depends upon the number of comparisons. And the number of comparisons ultimately depends upon the kind of input that we have received. Isn't it? So the kind of input means how many numbers are there that we need to sort. Are these the small numbers? Small numbers means count of numbers. Are you supposed to you can say sort only 5 to 10 numbers, or you have to you can say sort 1 million numbers? Isn't it? Do you agree?
Yes, ma'am.
So that means time and space complexity that depends upon the kind of input that we have received. If the input is small, the time and space will be less. If the you can say if the input is large, and depending upon the kind of input that we have received, so we will have to change the algorithm also, because one algorithm may be faster on small data set, small input, but become very slow on the large input. So that means it depends upon the kind of input that we have received, that you can say which algorithm is best. So depending upon the kind of input, and second parameter is the contents. You can say the extent to which the items are already sorted. Isn't it? If the input that we have received, that means if it is already sorted, then if the data that we wanted to sort that is already sorted, then what will happen? Yes, be interactive. Be interactive. If I'm asking something, you must
Ma'am,
respond.
time will be wasted.
No, that means the time will not be wasted. So, do you think all the algorithms, see if the data is already sorted, so which algorithm is best for that? What all algorithms, sorting algorithms you have studied? In the previous course, what algorithms you have already studied? Yes, Paul?
Selection sort, bubble sort, merge sort, counting sort, quick sort, Redix sort.
Oh, great. So the most of the sorting algorithms you have already studied. So what do you think, which algorithm is best for the totally sorted data?
Ma'am, maybe Redix because it doesn't compare anything.
And Nishant, what do you think?
Ma'am, Redix है also.
Okay. So, and if it is unsorted, completely unsorted, we wanted to sort the data in ascending order, and the data is there in the descending order. The input is in the descending order. Then which algo will work best? Himanshu? Himanshu, are you there?
Yes, ma'am.
Hmm. Which algorithm will perform better? In the opposite scenario, where we want to sort data in the increasing order, but the input is received in the, yes,
Quick algorithm.
quick algorithm. And who all are going to support him? Shreya and Ritika. Shreya, are you there?
Yes, ma'am.
Hmm. Are you able to recall the sorting algorithm?
Yes, ma'am.
So which
We
algorithm will perform better?
we can also use merge sort.
Okay. So what do you think? Which is better, or both will give the same performance? Yes? Ritika?
Yes,
Ritika,
ma'am.
what do you think?
Um, quick sort.
Why quick sort?
मैम इन मर्ज सॉर्ट हम उसको डिवाइड करके फिर सॉर्ट करेंगे तो फिर मे बी उसमें ज़्यादा टाइम लगे.
Okay. So because we are not sure, so in the today's tune we'll be doing this exercise only. So we will see that if the input that we have received, if it is the best case, what will happen, right? how many comparisons are required by a particular sorting algorithm, and if it is the worst case, so in the best as well as the worst case, how many comparisons are required, right? So we are going to do this exercise in our tube today. So we're talking about the algorithm. So what are the properties of an algorithm? When we say that this is an algorithm, what are the basic properties? So when we say the properties, so that means it should produce at least one output. When we are saying that we are trying to solve a particular problem, so in that case, the solution will provide, the solution means it is giving certain outputs. Then, so when you are writing the algorithm, you have to make sure that the statements that you write, they should not be ambiguous. So they should be precise, right? So these statements, when we are speaking, we can use the words maybe, right? Might be. But when we are writing the algorithm, such kind of words are not allowed, right? So you have to be precise, because it is telling what is the task that needs to be performed, because ultimately this algorithm you are going to convert into some code using some programming language, and in the programming you won't be able to handle the ambiguous statements. Then it should be a loop invariant. You're going to have certain loops which you have to mention precisely, that where the loop starts, what are the initial values, and when the loop will end, what are the conditions over there. So you should make it clear. So it should produce an output within a finite amount of time. So we always say you are in the fourth semester, and when we are writing the program, we always expect the output to be returned that within a finite amount of time. If it is not providing the result in the finite amount of time, we say it has got in certain loop. So that means certain conditions are gone wrong, due to which it is not stopping, right? So we should get the output within a finite amount of time. So that means there is something wrong with the logic that we have developed if we are not getting the output. So it should take a finite number of inputs. So the algorithm, we should provide the limited number of inputs only for a certain range of inputs. We are trying to find out the solution when we are writing the algorithm. It should be language independent, yes. So you can say it doesn't, see, when you're writing a pseudocode or you're writing the algorithm, see, we write an algorithm with the help of a pseudocode, or you can write a flowchart. Both these things that you design, so they are meant to understand the logic of the problem, what kind of steps you are going to take in order to find the solution. So they are independent of the programming language that you use, whether you write the program in C, C++, Java, PHP, JavaScript, any of the programming language you talk about in the world that exists. So you can say the algorithm will remain same. That means the pseudocode you write or the flowchart you write, that will remain same, whether you convert that into C language or Java language or PHP language, in any of the, or you write it in a Python programming language. So your pseudocode that way or your flowchart is not going to change, because they are written to understand the logic, the solution steps for solving a particular problem, right? Then the important thing that we see that we have to discuss is the correctness. So algorithm should be correct. So what do you mean by when we say the algorithm should be correct? Who will tell me? Ronak? Ronak? Are you there? Ronak?
Yes, ma'am.
What do you mean when we say the algorithm is correct?
What, ma'am?
Correctness of the algorithm.
Correctness of algorithm. Ma'am, it depends upon time complexity.
No, correctness doesn't depend upon the time complexity. Correctness does not depend upon the complexity, how much time it takes and how much space it takes. It doesn't, it has, see, correctness is only related to the input and the output. If you have given a correct input, the algorithm should provide a correct output. Okay. So correctness only is related to the input and the output. That means if the algorithm is given the desired input, some legitimate input, or you can say some given range of numbers, in that case it should give us the correct answer. So that means for a sorting algorithm, if you have given certain numbers, so let us say if you are given certain range of numbers, so the algorithm should give us the sorted result of these numbers. If you are doing it for the ascending order, it should give the result in the ascending order. If it is in the descending order, so the output should be in the descending order. So that reflects the correctness of the algorithm. Here we are not talking about how much time it took. Okay, so we are saying that if we have designed an algorithm to solve a particular problem, for the correct input, it should give us the correct output. Okay, so that reflects the
Yes, ma'am.
correctness of the algorithm. Then why do we really need to analyze the algorithm? Yes, why do we really need to analyze the algorithm? Yes. What is the goal of the analysis? So we need to analyze the algorithm in order to understand the behavior of the algorithm. What will happen? See, analysis is required to be done in order to understand what will happen if some other input is given. So that means when we are playing with the inputs, so if the input changes in terms of size, what will happen? How we are going to get the result, how much time it is going to take, how much space it will require, how the algorithm will behave with a change in the input, right? So this is basically the main reason for you can say we do the analysis of the algorithms. So when we are analyzing the algorithm, we want to know the behavior of the algorithm, the efficiency of the algorithm, the performance of the algorithm. So while doing the analysis of the algorithm, we have two types of analysis that we do. One is posteriori analysis, another is priori analysis. Priori analysis we do using the pen and the paper, the theoretical analysis of the algorithms. Once we have learned any algorithm, once we have designed any algorithm, you can say we will try to prove on using the pen and paper that this algorithm is better than the other algorithms, or how much time it may take at max, how much time it may take to solve a particular problem, how much space it may take in order to solve a particular problem. So this we do the theoretical analysis using the pen and paper, right? And the posterior analysis we do by writing the programs. So what do? We write the program, and then practically, right, by implementing that particular algorithm, we see what is the behavior of that particular algorithm, what time it is actually taking, right, in order to provide the solution, how much space it is actually taking for executing that particular solution. So we do the analysis of the algorithm from two perspectives. One is the theoretical analysis and another is the practical analysis. Practical analysis we do by implementing that particular algorithm which we are trying to use for solving a particular problem. So we say the time complexity, that is the time measured in terms of the compile time plus the run time, and the order of magnitude, that means how the time will increase, whether the time and as well as the space, where the efficiency we are measuring in terms of time and space, how the time will change with the increase in the size of the input, right? It is going to increase linearly or it is going to increase exponentially. So what is the order of magnitude with respect you can say of the time and space with respect to the input that we are providing. So in the next class, we are going to discuss, you can say, the various searching and the sorting algorithms that we have touched upon today. So in the next class, we'll be starting with the asymptotic analysis, and that we will do with respect to the sorting algorithms, and we will learn about the various notations. We can say if you have already done it, you can revise them again, and so that you can grasp them by their heart. So that's all for today. So I'll be taking the attendance. Be alert for your attendance.